Hey everyone, it's Miss Joyce. Today we'll be adding and subtracting fractions with unlike denominators using a written method. First, let's add 1/2 plus 2/3. If we look at both these fractions, we can see that the denominators are not the same. This means that there are a different amount of parts to make up each whole. Since there's a different amount of parts in each whole, that means the sizes of each part are not going to be the same. When we're adding and subtracting fractions, we need to make sure that the denominators are the same. So we're going to create equivalent fractions so that both fractions that we're adding have the same denominators, which means that there's the same number of pieces in each whole. To do this, we're going to list out the multiples of each denominator. Since 2 is the denominator of the first fraction, we're going to list out the first 5 multiples of 2. Here we have 2, 4, 6, 8, and 10. Now let's list out the first 5 multiples of 3, since 3 is the denominator of our second fraction. Here we have 3, 6, 9, 12, and 15. Now let's look at both of these multiples lists and find the first multiple in both lists. Well, if we look carefully, we can see that 6 is the first multiple in both lists. That means we can rewrite each fraction so that it has a denominator of 6. So let's do that first for 1/2. Well, we know the denominator is going to be 6 because that was the first number in both lists. Now let's ask ourselves, what do we multiply by 2 to get to 6? Well, 2 times 3 equals 6. So since we're multiplying by 3 on the bottom, we're going to multiply by 3 on the top. 1 times 3 is 3. So that means 1/2 is equivalent to 3/6. Let's do the same thing for 2/3. Well, we know the denominator in our equivalent fraction is going to be 6, since 6 was the first common multiple in both lists. Now let's ask ourselves, what do we multiply by 3 to get to 6? Well, 3 times 2 equals 6. So since we're multiplying by 2 on the bottom, we're going to multiply by 2 on the top. 2 times 2 equals 4. So 2/3 is an equivalent fraction to 4/6. If we look at both of these equivalent fractions, they both have a denominator of 6, so we can add them together. 3/6 plus 4/6 equals 7/6. So that means there are going to be 7 parts shaded, and there are 6 parts in each whole. So 1/2 plus 2/3 equals 7/6. Let's try another problem. Here we have 1/3 plus 3/4. If we look carefully at the denominators, we can see that they are not the same. Remember, we need common denominators in order to add and subtract fractions. So what we're going to do is create equivalent fractions. To do that, we're going to list out the multiples of each denominator. Since 3 is the denominator of the first fraction, we're going to list out the first 5 multiples of 3. We have 3, 6, 9, 12, and 15. Now let's list out the first 5 multiples of 4, since 4 is the denominator of our second fraction. We have 4, 8, 12, 16, and 20. Now let's look carefully at both lists to find the first multiple in both lists. We can see that 12 is the first multiple in both lists, meaning we're going to create equivalent fractions that have a denominator of 12. Let's start with 1/3. We know the equivalent fraction that we're going to create is going to have a denominator of 12. So let's ask ourselves, what can we multiply by 3 to get to 12? Well, 3 times 4 equals 12. So since we're multiplying by 4 on the bottom, we're going to multiply by 4 on the top. 1 times 4 equals 4. So 1/3 is an equivalent fraction to 4/12. Let's do the same thing for 3/4. We're going to create an equivalent fraction that has a denominator of 12, since 12 is that common multiple in both of our lists. Now let's think, what do we multiply by 4 to get to 12? Well, 4 times 3 equals 12. So since we're multiplying by 3 on the bottom, we're going to multiply by 3 on the top. 3 times 3 equals 9. So 3/4 is an equivalent fraction to 9/12. If we look at both equivalent fractions, they both have a denominator of 12. So now we can add these fractions together. 4 twelfths plus 9 twelfths equals 13 twelfths. So 1/3 plus 3/4 equals 13 twelfths. Now let's try a subtraction problem. Here we have 4/5 minus 1/3. If we look carefully at our denominators, we can see that they are not the same. So we need to create equivalent fractions so that the denominators are the same. To do this, we're going to list out the multiples of each denominator. Since 5 is our first fraction's denominator, we're going to list out the first 5 multiples of 5. Here we have 5, 10, 15, 20, and 25. Now let's list out the first 5 multiples of 3, since 3 is the denominator of our second fraction. We have 3, 6, 9, 12, and 15. Now let's look carefully at both of these lists to find the first multiple in both lists. We can see that 15 is the first multiple in both lists. That means 15 is going to be our common denominator. So let's rewrite 4/5 as 15ths. So we know the denominator is going to be 15. Now let's ask ourselves, what can we multiply by 5 to get to 15? Well, 5 times 3 equals 15. Since we're multiplying by 3 on the bottom, we're going to multiply by 3 on the top. 4 times 3 equals 12. So that means that 4/5 is equivalent to 12/15ths. Let's do the same for 1/3. We know the denominator is going to be 15 since that was our common multiple. Let's ask ourselves, what do we multiply by 3 to get to 15? 3 times 5 equals 15. So since we're multiplying by 5 on the bottom, we're going to multiply by 5 on the top. 1 times 5 equals 5. So that means 1/3 is equivalent to 5/15ths. If we look at these equivalent fractions, we can see that the denominators are the same. This means we can subtract these fractions now. 12/15ths minus 5/15ths equals 7/15ths. So that means that 4/5 minus 1/3 equals 7/15ths. Let's try one more problem. Here we have 7/8 minus 2/4. If we look carefully, we can see that the denominators are not the same. We're going to create equivalent fractions so that the denominators are the same. To do that, we're going to list out the multiples of each denominator. We're going to start with 8 since that's the denominator of our first fraction. Here we have 8, 16, 24, 32, and 40. Now let's list out the first 5 multiples of 4 since 4 is the denominator of our second fraction. We have 4, 8, 12, 16, and 20. Let's look carefully to see which multiple is the first multiple listed in both lists. Well, we can see that 8 is the first multiple in both lists. So 8 is going to be our common denominator. Well, if we look at our first fraction, the denominator is already 8. So that means there are already 8 parts in this whole. We don't need to create an equivalent fraction. So we can go straight to 2/4. Let's think. Our denominator is going to be 8 since 8 was the first multiple in both lists. Let's ask ourselves, what do we multiply by 4 to get to 8? Well, 4 times 2 equals 8. So since we're multiplying by 2 on the bottom, we're going to multiply by 2 on the top. 2 times 2 equals 4. So that means that 2/4 is equivalent to 4/8. If we look at our fractions, we can see that both of these fractions have a denominator of 8. So we can go ahead and subtract these fractions. 7/8 minus 4/8 equals 3/8. So that means that 7/8 minus 2/4 equals 3/8.